The following tutorials are provided as is with no guarantees. Tutorial author will not take any responsibility for issues that may occur when using tutorial code. Hello guys, and welcome to another Solana tutorial. Today we're actually going to start working on Solana programs, or as they're also called, smart contracts in other blockchains. So I'm already in my development environment here that we set up earlier. I actually changed it up a little bit because we don't really need Verdaccio this time. So if I go git branch, you'll see that there's a different branch that I'm on now. So no AVX2, no Verdaccio. And the difference there, if I go into Visual Studio Code, the only difference is that I basically commented out this Verdaccio service, so it's not going to be starting up. And I also, in the startup sh, commented out these npm registry links. Now that we got that sorted, I'm actually going to start up the containers. Let me just check that I don't have them running yet. No, I do not. Docker compose up-d, and the container is starting, so it's running. Good. Now I'm going to sign into that container. So docker exec-ti solana dev env bin bash. Okay. And now I'm inside the container. I'm just going to clear. One other thing that I need is actually need another repository. So I'm going to open another terminal tag. I'm not inside the Docker container here. I'm going to list what I have. cd to app dev. List nothing here. And inside app dev, I'm actually going to load a repository. So if I'm going to go here, I actually have this Solana tutorials repository. So I'm going to copy this. I'm actually going to do it through the host terminal, not the Docker terminal, the host. I'm going to do git clone and get this repository. And now I also need a different branch as well. So git, actually, let me just list it, cd solana tutorials, switch inside, and I'm going to go git branch. There's another branch that is available, which is actually for the very first tutorial. Come on. Okay, so here we are. This is called T01 Hello World, right? Let me just go 2 branches for now. Oh, come on, I just want to copy this. Git checkout and the name of the branch, and here we go. And now I'm actually going to sign into the Docker container. Solana local env, there it is, attach, and we now just wait a little bit for the container to get set. So here's our hello world and Solana tutorials. We can actually open one more directory in the workspace so that we can work on the actual Rust source. So I'm going to open the Rust directory because in here we have our cargo. The reason why I do this is because we will have some help from a Rust extension with it when we have our project open in the Rust root. So here we go, cargo here. Now I have this extension installed. So if I go Rust, you see this Rust analyzer. This is quite helpful, so I suggest you install it. I already have it installed here. Now, if I open librs, as you can see, it starts to analyze it, and pretty soon we will have some demarcations going on the Rust program. While this is happening, I will also open TypeScript. It's in the client section. This program here is basically the same as the original Solana Hello World. I just removed a bunch of stuff so that we can only focus on the TypeScript and the Rust code and nothing else. I'll just open all these files quickly. Now this Rust analyzer can take some time to complete. As you can see, it's still indexing, is still spinning here, refreshing. So just be patient with it. Once it's done, as you can see, we get these different demarcations. So this is not an actual code that I wrote. It's part of what the extension is doing for me, marking the different types and things like that. So this is our program here. This is what Solana program looks like, this lib.rs file, so this librust file. What we're doing here is we're importing the Borscht library. This is a serialization, deserialization library. We will go about what it means right away. Solana program, these are the programs that have to do with using Solana itself, writing the smart contracts for it. This MSG is like print line, except it's specifically made for Solana because Solana team believed that original print command was too heavy to run within the smart contract, so they just wrote their own. It works pretty much exactly the same as the print line macro in the Rust programming language. Now, this Solana program declare ID, this is to keep the IDs in check so that when you are uploading your smart contract to the blockchain, it maintains this ID, because sometimes when you do the deployment of smart contract, it wants to create a new ID and pay rent again and basically spend more money that way. But we will go over this as well, how these things are being stored in the Solana blockchain. Over here we have, this is a Rust specific command. This is this type of command that derive Borscht serialize, Borscht deserialize, debug. This adds code to this struct here. So Borscht serialize, deserialize adds functionality to the struct to be able to serialize the data that is defined inside the struct or deserialize it. And the debug is something that allows us to print various information about it, because this is not like a regular type, like a string or anything like that, so we can't really just print it. We have to have special kind of code added to it to be able to retrieve the data of this account, and that's why we have this debug. Debug is not Solana specific, it is actually something that comes with Rust. This part right here, entry point, this is where we actually let the Solana network, the Solana blockchain, know that we need to process instruction here. So our program uses this entry point to find out what to do next. And this process instruction function right here is pretty much the meat of our smart contract. So over here we have the program ID. Program ID is basically a public key on the Solana network. One thing to keep in mind is everything on Solana network has its own address in a way. So your wallet has an address, the wallet which has your soul. A program would have its own address as well, except it would also have some soul in it to pay for rent, but it would also be executable. Accounts here are what we can manipulate using this program. So, for example, this program ID would be a public key of the program, while these accounts would be public keys of data accounts that we want to manipulate. Instruction data, on the other hand, is serialized byte data. So this thing right here, signifies the array of U8. U8 is basically a byte. It's an unsigned 8-bit integer. So basically it is a byte. And we denote bytes in Solana in a way as this U8 thing, because that's basically what it means. Then when this whole thing runs, we get a program result, which is a type of result, returns either OK or error. And if you studied Rust, which you should know something about it, it basically signifies whether we ran the instruction or if it failed. Here we are using the message macro, where it actually just prints out some text. Next, we have to iterate through these account public keys. We submit the account public keys, all the account addresses that we are planning to do something with, either retrieve data from or manipulate. So these account iterator is what helps us to go through accounts without influencing the same account twice. So we get an iterator here, and then we step through it using this next account info function. So we get a reference to a new account each time. So here we have next account info, which returns just one account in the case of this particular smart contract. And then we check whether account owner is not equal to the program ID. One thing to keep in mind when working with Solana is that when we're manipulating an account, or we're creating an account, it always has an owner. And an owner is not really a person. It is another program. So if a program creates an account, it's going to be the owner of that account. Unless you run a different command and it switches out the owner. But the idea is that the only one who can manipulate the data in a particular account is a program that is authorized to do so. So that there isn't some malicious user that writes their own program and tries to manipulate someone else's account using that program. This is why we have this check. So we run this check. If it fails, someone's trying to play dirty. So this should basically just return error and exit. If everything is fine and if the account is owned by the program, what we do is we do an increment in this case. So what we are doing here is we're getting this variable, greeting account. We are deserializing its data. So this thing right here, greeting account try from slice account data borrow, we are borrowing the byte data, and then we are try from slice, we are converting this byte data into struct over here, to this greeting account struct. That's what this does right here. And then once we have this, we increment it by 1. So we have this greeting account counter plus equals 1. We are adding 1 to counter. And then we are serializing it again. So we take greeting account, serialize, and then this weird thing with 2 mutable reference pointers, account data borrow mutable. So this is in a way a little bit difficult to understand exactly what it does, but it just serializes the data that we added here. And then we again print the message saying that what our counter number is now. And we return OK as what is required when we're returning a result in Rust. Now, once we have this done, we're not going to go through tests right now because we're going to go in the tests in the future tutorial. For now, this is good enough. Next, we have to actually compile this Rust code and put it into our blockchain. So first things first, we're going to compile it. To do that, we could run the program from package.json over here inside the... let me just open this package. Over here, we have all these different programs, so we could build Rust. We could run the npm, but I'm actually going to run it using this command. So I'm just going to copy this. What we're basically saying is cargo build BPF. BPF is a special format for compiling libraries, in which we use to compile Solana smart contracts. Manifest path, this is where our cargo TOML is, and then where we're outputting our compiled code. This is what we do. We need to run this in the proper location. So I'm going to go inside this and go inside the hello world. And in here, I'm going to run the command. Now we will need to wait for some time for this BPF SDK to download. Keep in mind that right now, if you shut down and remove your container, it will have to download it again if you start up the container and try to compile again. For now, I tried to place it inside the container recently, but for some reason it doesn't compile packages properly then. So until I figure out how to fix up the development environment so it's already present there, this is fine. Okay, so now I'm going to wait until this downloads and compiles the .so files, and I will see you after that. Okay, so now we have our thing compiled. Over here, see that this .so file, here's the command to deploy it, Solana program deploy, hello world.so. Let's just check one thing. In Rust, target, release, no, actually, no, not here, sorry. We outputted it where? We outputted it in dist program. So here we have dist, and here we have program, hello world key pair JSON. We need to get the ID of this program, the public key. We're going to do Solana address -k, then we're going to do dist program, and then we'll do hello world key pair.json, and here is our public key. What we will do is copy this, go into our Rust file again, and paste it here. Save the file and recompile one more time. There we go. We recompiled the file. We don't have to wait anymore because that BPF SDK has downloaded last time we did the compilation. Now I'm going to take this and copy it. And we're going to take a look at our key pairs that we're going to use. Now, I have 2 key pairs installed here in our wallet. Let me just close this off a little bit. This is inside Docker. Let's take a look at the VS Code outside of Docker. So here's our VS Code outside of Docker. We can take a look at the development environment wallet. Over here we have these. So we have this local key, and we have this validator key available inside because I linked them here using this validator YML as our config, and local net YML is the local net.yml here. Don't use them in real applications. Don't use these keys because people that watch these tutorials will know about these keys. So yeah. Okay. So let's take a look inside our wallet. If I do ls in the root wallet, so we have these ones, but the one that we are using for this particular tutorial is the local key and validator key. If I do Solana config get, you see that we are linked to localhost and we're using this validator key JSON. Now, let's go to our terminal inside the Docker container that we opened earlier. And now we are in the root. So this is the root directory with this test ledger directory. Now I'm going to start. Let me just see if any ledger has been created. No, not yet. So we're going to do Solana test validator. I just started our validator. The next thing that we're going to do is I'm going to log into the Docker container one more time. And what I'm going to do using this one is actually I'm going to log. Oops. It's a logs. I'm going to log what we are receiving using this what this does is it will show me when we are running the code, it will show me whatever is happening on the blockchain. Like for example, this message, I will be able to see it, this MSG macro right here. Okay, so now that we've done that, let's actually deploy our program. Before we do that, actually let's fund our wallet, because if I do Solana balance, what we will see is the validator wallet, which will have a lot of Sol in it. As you can see, there's like plenty of Sol in there, but I want to fund the local key. So what I'm going to do is Solana airdrop -k wallet local key.json, and now I'm going to give about 20 Sol into there. So I just did that. Now if we look, let's see if there's any log here. See, so the log has shown that I deposited, that I did something here. It doesn't show exactly what I did, but the signature is right here. Actually, no, let me just restart it. I'm gonna clear and start Solana logs again. This will be easier to see any kind of transactions that are coming through. Okay, now if I do Solana balance for this same local key, we can see that I have 20 Sol in there now. Okay, good. Now let's upload this SO file. So Solana program deploy, but I will use this key to do so. So I will do Solana program deploy. Let me hide this sidebar. -k wallet local key JSON. And now let's run this. Okay, we offloaded the program. You can see that this there's actually a bunch of transactions that have happened here with all these deployments. This is what's been logged when we were uploading this transaction here. Let me clear it again, because after this I will want to actually focus on what our smart contract has output. So we have just uploaded the smart contract using this local key wallet. So if I take a look at the balance of this wallet, you can see that it is actually 19.32. The address of the program is right here. This is the same address as we have recorded right here. HZK, 6HM, 6HM. So this is the address of our program. Now, what we can do is we can actually take a look at it using Solana Explorer. So if I go to Explorer, solana.com, and I switch to custom RPC URL, this is our local. Let's switch here, and I'm going to input this address. We can see what this program is. So this is the address of our program. This is the balance. I believe this is actually rent that we had to pay for this. Executable data, this is the program hash. It says also over here it's executable. Yes means that it is a program account. Upgradable, yes, meaning that we can change the program. So if we change the code inside the program, we can re-upload, and the program will work differently than it works right now. So this is it for now, for this particular part. Okay guys, let's go over these TypeScript files quickly. So we're importing some functions from our hello world TS file over here, and then we are running all these commands. So these are asynchronous commands. However, what we're doing here is we're waiting for this command to complete, then we're waiting for this command to complete, then we're waiting for these commands to complete, and so on. So each command will run only after the first one completes, because there is actually a way to run things asynchronously in JavaScript, so they kind of all run at the same time. However, in this case, we don't need this to happen. Now, let's go over each of these commands, but we will start at first with utils, then hello world, and then the main TS, right? So utils. In the utils, we have a few helper functions. GetConfig here gets our Solana configuration and reads the file and returns, basically parses the YML over here. what we're looking at here is the information that we get when we run Solana config get. So as you can see, we have our RPC URL, key pair path, configuration file, that sort of thing. So once it gets and parses it, we have this get RPC URL. This is exactly what it does, gets this RPC URL from here. Or if it fails to get it, then it returns the 127.0.0.1 URL, which is also localhost. Then we also have get pair, and get pair is tied directly to this create key pair from file. So let's look at it first. Over here, we read the file on the file path and return the key pair from secret key. So this is the key pair that we are actually going to be signing the transactions with. That's what we're returning over here. The get pair, we get our configuration. If we do not have the configuration, we throw an error. And over here, we return the key pair from file. So we run this one to get the key pair that's going to be signing the transaction. On the other hand, if we have an error, we just return the warning and generate another key pair instead and return that one. Now let's go to hello world. Over here we're importing some functions and modules from Solana Web3.js. This is a node module for dealing with Solana smart contracts. Then we import the file system, the path, and Borscht serializer. Over here we are setting some preset variables to hold various information like our connection, our pair, program ID, and so on. Greeted pub key. Now greeted pub key is actually going to be generated on the fly here, as you will see in a second. Program path is a constant which we resolve to our dist program. This is where we actually saved our .so file. Program SO path, this is actually exactly what it is. We take this one and combine it with the name of the file. And program key pair path, this is for our key pair JSON, which is this file right here, key pair JSON. Greeting account is a class. This is where we actually start defining a schema on how we're going to be serializing and deserializing data that is used for our smart contract. So these two things here together, they're what is defining our serialization, deserialization schema. So right here is the class counter that has a variable here, the constructor here, which is the counter. And over here we have the Borscht schema, which is greeting schema, which is a map, which takes this greeting account in here and defines what it is. So in our case, the counter is U32. Greeting size is a way to calculate how much space we need on chain in order for us to pay rent. So what we are doing here is we're serializing the greeting schema with a new greeting account. We generate this class here and we get the length of it. Establishing connection to cluster. This is basically connecting to the RPC URL and making sure that we have connection to it. Over here, establishing pair. This is where we need to establish who's paying for the transaction and how much we're paying. So over here, if we do not have a pair, we have this fee calculator. We get the recent block hash, which is actually deprecated. It should be replaced with a different function. We will do it down the road when we're working on more tutorials. We then calculate the cost of funding the greeter account. One thing that we have to consider is that we need to create another account to store our data. So the smart contract account is separate. The data storage account will be separate, and we will have to pay rent for that one as well. In this case, rent exemption means that we're going to pay 2 years worth of rent for this account so it doesn't get deleted over time. Then we calculate the cost of sending a transaction. We need at least one signature. So in this case, LAMP ports per signature times 100, and we get the cost for that, and we add it up to the total cost of our transaction. And then we do the get pair, which is something that we saw in the utils over here, where we do the get pair function, and we either generate a new key pair or we get the one from our configuration over here, which is validator.key.json in this case. LAM ports are the fractional parts of Solana. So we are setting these LAM ports, and then we get the balance of the payer, the person of the account, the key that's going to be paying for this transaction. If the LAM ports are less than the fees that we have to pay in this case, this is a helper function to just airdrop some SOL into the account. In our case, we will most likely not be doing it, but you will not be able also to do it on the real mainnet of the Solana, because airdrops, well, this is only for development, right? So this is a helper only function here. Then we do the await connection confirm transaction. So we send this airdrop. This is also deprecated. We'll need to replace it in the future tutorials. LAM ports, we get the balance that is now after we did the airdrop. And then we just console log all this of how much using the account, what the account public key is, and how much LAM ports we have there. Okay, the next is check program. What we need to do first is we need to make sure that the program exists. So what we do is we go and we get the program key pair path, which is this key pair JSON. Then we get the program ID, which is the public key of this key pair. If we do not have the program, then it returns an error. Then we need to see if the program is also deployed on the blockchain. So what we do is we use the same program ID, we get the account information. If the account information is null, non-existent, we have an issue and the program needs to be deployed. We haven't deployed the program to the blockchain. If the program is not executable, well, then the program is not executable. So these are essentially different error messages that you can get due to program issues or due to program not being deployed properly. Otherwise, it just returns using program and gives you a program ID here. Next, we need to generate an account which will store data for us using our smart contract that we created. So what we have here is a greeting seed. This is could be any random string or numbers, anything like that, which you can use to randomize your public key generation. So over here, what we're doing is we took a pair's public key, we added the greeting seed to it, and added a program ID to it, program ID public key. And then we create another public key based on these values. And then from here, we can actually generate an account. So check if greeting account has already been created. So now if the person paying for this generation of this account and the greeting seed and program ID is the same, it will always come up with the same ID. So in this case, we have, if this account has already been created, this is something that we have to check. So we check get account info, is it there or not? If it is not there, we create the account. We get minimum balance for rent exemption for this greeting account. And then we do the transaction. So we do transaction, new transaction, add, system program, create account with seed. So we create this very same account. And then we send and confirm transaction. And at that point, our greeting account, the data account, in other words, has been created. Then we finally say hello. This is another function here where we actually store information on the account that we just created. So we have the instruction, the new transaction instruction. We get the keys, the greeting public key. This is the one which we need for the account where we're going to store the information. Is signer this and is not, is writable, yes, meaning that this account we're going to be writing to. Then we have the program ID, the program that we're going to use to store information in this account. And the data buffer, this is pretty much empty. This doesn't do anything because we are not really sending data to our smart contract. We're more like just invoking it, and it is actually going to increment the digits inside it just because it's been invoked. And then over here we have another function which will actually take the information from the account, from the greeted account which we created for storing information, deserialize the data using the greeting account schema, and printed out for us. So now what we can do is we can go to main TS and take a look at what we're doing. So we're establishing connection, then we are establishing pair, then we check whether the program exists, and then we say hello, and then we report greeting. So check program here and establish pair. Let's just take a look here because this creation of account part is pretty important. Let me see here. Check program. So check program is the part which actually creates the extra account which will store the information for us. So over here when we do check program, it checks whether the program is actually uploaded to blockchain and also creates the greeting account for us. And now I'm actually going to run this TypeScript file. So I'm going to, I could either run npm run start, but I will just run the actual command so that it's clear what I'm doing exactly. I'm in the same page as package.json. Let me clear, and then I will run it, and we will see what happens. Actually, let me just move this to the side. We're actually going to be looking here as well. This is the Solana logs area. Let me run this. And as you can see here, we received some information printed for us. Looks like I was disconnected there. So we already did one. Let me just run it one more time. Here we go. So this is on the Solana side. So program log hello world Rust program entry point and greeted 2 times. Because I ran it twice. Over here you can see if we go into our Rust program, the lib.rs. Over here, hello world Rust program entry point. Oh, it's over here. And then greeted 2 times. This part is greeted times, right? Number of times. So this is outputting from the smart contract itself. And over here, on this side, I'm just going to expand it. We ran it twice, so I'm just going to go starting from this line. So we ran it, and then we have say hello to Solana account. This is some stuff that we have in our main. Let's say hello to Solana account. We go through the rest of our lines here. Connection cluster established. Okay. Using account, using program, and we has been greeted 2 times, right? So we have all this. I think it's report greeting. Let's take a look at the report greeting. Yes. So this account, right, has been greeted, counter, and then times. So 2 times. Good. As you can see, our SOL actually went down from 500 something million, so we actually used some SOL to send these transactions and to create the storage account. Now let's take a look at something using our Explorer. We have this using account and using program. Let's copy this account information and let's go to our Explorer. Now we're on our Explorer. Let me type in this account and see what it says. Actually, this is my wallet. Okay, my bad. Let me using program saying hello to. Okay, this is what we need. We need this one right here. Copy. And I'm going to paste it here. Okay, so here it says executable no, allocated data size 4 bytes, and then balance SOL, and then this is the address which we actually typed in here. Assigned program ID, this is the owner. This is the owner of this account right here that we have. And it is 4 bytes big. 4 bytes is because the size of the data that we store, if you remember, is U32. U32 is 4 bytes because it's 4 times 8 equals 32. So this is 32 bits total, 4 bytes altogether. That's why it comes to 4 bytes here. This is the rent that we are paying. This is the total amount, 2 years rent worth for 4 bytes of size of data. Now, change to this account can only be done with the assigned program ID, which is this one right here, which in our case is our smart contract that we just deployed. Right? So that's how it works. This is pretty much all we do when we work with smart contracts. Is we write the smart contracts, we get them to influence data at different accounts that can be either program derived or not, but as long as the program has the ownership of that account, it can manipulate it in some way. So this is it for this tutorial, and in next tutorials we're actually going to start using our instruction data here, which we didn't really use this time. We just were incrementing the amount and saving it to the blockchain and nothing else. However, the blockchain is capable of a lot more than this. So thanks guys for watching. Like and subscribe, share, and I will see you guys in the next tutorial. Bye-bye.